Welcome back, class. Today we're going to learn about the third way of writing quadratic equations. We've already learned standard form and factored or intercept form. Today we're going to learn vertex form.
Mr. C, where are you? We can hear you, but we can't see you.
Perhaps he is using a cloaking technology to make himself invisible.
Or maybe he turned himself into a bat and cannot change back. Mr. Caldwell, do not worry. This happened to my Uncle Vlad once. Try holding your breath and counting to 10.
No, class, it's not that. It's a little embarrassing. Let's just focus on learning vertex form.
Mr. C, are you really okay?
Did you fall down? Do you need us to get help?
No, it's Dr. Rick in the science department. He likes to play jokes on me. He said he bought me a drink from the juice machine in the teacher lounge, but after I drank it, I realized it was one of his shrinking potions. Don't worry, his potions wear off. I can just stand on top of my desk until then, so that you can all see me while I'm teaching. Alright, where was I? Today's lesson is about writing quadratic equations in vertex form.
Nobody shrinks my algebra teacher. I am programmed for revenge. Activate maximum vengeance against Dr. Rick of the science department.
No, V9. I appreciate your concern, but this was just a prank. Let's all calm down and focus on our algebra.
Affirmative. Revenge suspended.
So, as I was saying, today we're going to learn how to write a quadratic equation in vertex form. So let's talk about what a vertex is. When we graph a quadratic equation, we get a shape called a parabola, which curves in one direction, then reaches a certain point, and turns around to head back in the opposite direction. That turning point is called the vertex. It's very helpful to know where a parabola's vertex is whenever we have to graph a quadratic equation. We'll learn more about graphing in later lessons, but graphing a parabola is harder than graphing lines, which you may have done earlier in algebra. Lines keep moving in the same direction forever, so if you graph just 2 points of a line, you can draw the whole rest of the line by connecting those points. Graphing a parabola, though, is much trickier. No part of a parabola is straight like a line, and if you think you can just graph 2 points of a parabola and then connect them, think again. How would you even know if those 2 points were on the same arm of the parabola, or on different arms, or what? Again, that's why it helps to know where the vertex is, because then we have a center point where we can start drawing our graph. We also know that the 2 arms of the parabola will be on opposite sides of the vertex, so we know that any points we graph on one side of the vertex will all be on one arm of the parabola, and any points we graph on the other side of the vertex will all be on the other arm of the parabola. Lastly, since parabolas are symmetrical, their 2 arms are exact reflections of each other. The vertex can save us time because we can graph just one arm, then reflect it across to the other side of the vertex, and we're done. Like I said before, we'll learn more about graphing in a later lesson, but the point I'm trying to make right now is that it can save us a lot of time to know where a parabola's vertex is located. That's why one of the main ways of writing a quadratic equation is in vertex form. Vertex form shows us where the vertex of our parabola will be located. It's a different way of writing the same equation that we could otherwise write in standard form or factored form.
So they are synonyms, like the words revenge and vengeance.
V9, you're right. Standard form, factored form, and vertex form are all just different ways of writing the same quadratic equation. So we can even switch a quadratic equation from being written in one form to being written in another form, if doing that helps us to solve a particular problem. But can we please stop talking about revenge against Dr. Rick? Let's try to stay positive.
Hey, that's a math joke. What did the whole number say to the integer? Try to stay positive. I thought it was, hey baby, what's your sign?
Guys, I think Mr. C is having a hard enough day without the dumb jokes.
We've just learned that vertex form is a way to rewrite any quadratic equation so that we can see where its vertex is. Now let's try an example. Here's a quadratic equation. I've written it in standard form, which just means that the x squareds are listed first, then the x's, then the plain old number at the end. But the problem with writing a quadratic equation in standard form is that it doesn't help us if we need to graph the equation. Standard form is useful for other things, but if we have to graph this parabola, standard form gives us no idea where the vertex is going to be. So, for a second, I'm going to cheat and show you the graph of this parabola. That way, we can see for ourselves where the vertex actually is. The vertex is here, at the point -4, -1. Now let's look back at our equation again. Do we see anything in the equation that would have told us these coordinates? Do we see the numbers -4 or -1 anywhere in this equation? No. So now I'm going to rewrite our equation in vertex form. This is the first time we've ever seen an equation in vertex form in this class, so you may be surprised how it looks. It's y equals x plus 4 squared minus 1.
Whoa, Mr. Coldwell, I think you are making a mathematical boo-boo. That is not the same equation. It is totally different.
Well, Tom, I agree that it sure doesn't look like the same equation, does it? But actually, it is. So before we do anything else, I want to prove to you that this standard form and this vertex form are actually different ways of writing the same equation. There's a trick we can use whenever we need to get vertex form back to standard form. We learned it in an earlier lesson. It's the FOIL technique. Can anyone tell me how we could use FOIL on our vertex form here?
The vertex form says x plus 4 squared minus 1. So isn't that just x plus 4 times x plus 4 with a minus 1 at the end? So could we FOIL x plus 4 times x plus 4? And when we figure out what that is, we can just subtract 1 when we're done, right?
Exactly, Codette. We start by multiplying the first terms together, then the outside terms, then the inside terms, and finally the last terms. That's our FOIL technique. When we add up those parts, we get x squared plus 4x plus 4x plus 16. The plus 4x in the middle simplifies to plus 8x, so we end up with x squared plus 8x plus 16. We're almost done. But, as Codette said, we have a minus 1 at the end of our equation, so we need to subtract 1. That gives us x squared plus 8x plus 15.
That's like exactly the same as the equation we started with, the one that was in standard form.
Good bones, you're right. So we just proved to ourselves that these two equations, which looked so different at first, really are the same equation, just written in different ways. Using our FOIL technique on the vertex form of this equation turned it back into standard form. Good. Now, we said that the whole point of vertex form was that it could help us figure out where the vertex of our parabola was located. So, how does it do that? First, let's look back at our graph. Somebody remind me where the vertex of the parabola is located. What are its x and y coordinates?
On the x-axis, it's back at -4, and on the y-axis, it's down at -1. So its coordinates are -4, -1.
That's right, Ruby. The vertex of this parabola is at the point -4, -1. So, how is our vertex form of this equation trying to tell us that? Can we see the numbers -4 and -1 anywhere in our vertex form?
I see a -1 at the end of the vertex form equation. Is that what you mean, teacher?
Yes, it is, Wendigo. Whenever we write a quadratic equation in vertex form, there's a number like this hanging off the end. Here are some examples. Notice how these all have a positive or negative number dangling off the end. Well, that number, including the plus or minus sign, is the y-coordinate of our vertex. A number with a minus in front of it means the y-coordinate will be that negative number. A number with a plus in front means the y-coordinate will be that positive number. And if you ever see no number hanging off the end, then it means 0 is being added to the end of the equation, so the y-coordinate of the vertex will just be at 0. Okay, if that's how to find the y-coordinate of our vertex, what about the x-coordinate? When we look over here at our graph, we can see that the x-coordinate of the vertex is going to be -4. But how does our equation show us that?
I see that there is a +4 in our equation, but I do not see a -4. Am I mistaken?
You're right, Wendigo. Our equation says x plus 4 squared, not x minus 4 squared. And yet, on our graph, the vertex has an x-coordinate of -4. So why does the equation say +4 when the graph shows -4? Here's why. The equation is telling us the correct coordinate, but we were looking for it the wrong way. The x-coordinate of our vertex isn't this number, the +4. It's whatever we could plug in over here for x that would give us an answer of 0 inside the parentheses. If we plug in -4 for x, then inside the parentheses we would have -4 plus 4, which equals 0. So this equation is telling us that the x-coordinate of our vertex will be -4, which is exactly what we see in our graph. Now, that was a little tricky, so let's make sure we understand it. When a quadratic equation is written in vertex form, it starts with a quantity like this, squared. An x plus or minus a number inside parentheses squared. Whatever number we can plug in for x to get an answer of 0 inside those parentheses, that's the x-coordinate of our vertex. And again, if you ever see no parentheses, just x squared by itself, remember that it means that you have x plus 0 squared, so the x-coordinate is just 0. So let's put it all together. When we write a quadratic equation in vertex form, it has two parts. The first part is inside parentheses, x plus or minus a number squared. The second part of our vertex form equation is a number added or subtracted at the end, outside the parentheses. The way we usually write this is y equals x minus h squared plus k, where h and k are placeholders for whatever actual numbers are in your equation. We said that the part of the equation inside the parentheses tells us the x-coordinate of our vertex, because whatever number we can plug in for x to get an answer of 0 in the parentheses, that number is the x-coordinate of our vertex. The second part of the equation, the positive or negative number at the very end of the equation, is our y-coordinate. When we have both of these parts together, we know the x and y coordinates of our vertex, so we know exactly where our vertex is going to be located on our graph. Now, you might have noticed something clever about the letters h and k that we used earlier in our equation. They're actually the same as the x and y coordinates of our vertex. Look carefully. K stands for the number at the end of our equation, which is the y coordinate of our vertex. H is the number we would need to plug into our parentheses to get 0. It's not just the number we see inside the parentheses itself. For instance, if we have the quadratic equation y equals x plus 1 squared plus 3, then our value for h is not the plus 1 that we see inside the parentheses. H is the number we would need to plug in to get 0, so h is -1. In other words, h is just another name for the x-coordinate of our vertex, just as k is another name for the y-coordinate. I know you're probably wondering why we have so many ways of saying the same thing in algebra. Let's try some examples so that we can be sure we understand. I'll show you a quadratic equation in vertex form, and you tell me the x-coordinate and y-coordinate of its vertex. How about this one? Y equals x plus 5 squared minus 3. If we graph this equation, what would be the coordinates of its vertex?
The y-coordinate will be -3 because that is the number at the end of our equation, -3. The x-coordinate will be -5 because when we substitute -5 for x in our equation, the value inside the parentheses will be 0. Therefore, the vertex of this parabola will be located at -5, -3.
That's right, V9. Here's the graph of this equation. We can see that the vertex of its parabola is right where you said it would be, at -5, -3. Nicely done. What about this equation? Tom, can you tell me where the vertex of its parabola will be?
It is, yes, let me see. Carry the 1, divide by avocado's number, extrapolate by Maxwell's negation.
I do not think he knows the answer.
Tom, remember, we look for the x-coordinate and the y-coordinate separately. The y-coordinate of the vertex is the positive or negative number at the very end of the equation.
The number at the very end of the equation is +7, or, as we math geniuses say, +7.
Good. And the x-coordinate will be whatever number we could plug in for x that would give us an answer of 0 inside the parentheses.
The parentheses says x plus 3, so we will obviously need to make x minus 3.
Or as you math geniuses say, -3.
I thought you were supposed to be a revenge robot, not a sarcasm robot.
Tom, you're right. Here's the graph of this equation. The parabola's vertex is right where you predicted, at the point -3, 7. You've done very well with this today, class. Let's quickly review what we've learned. Anytime we graph a quadratic equation, we get a curved shape called a parabola. Parabolas are symmetrical, which means that their two arms are mirror reflections of each other. The middle point between them is where a parabola changes direction. It's also where the mirror images meet each other. We call this turning point the vertex. It helps us a lot to know the location of the vertex whenever we have to graph a parabola. Unfortunately, if a quadratic equation is written in standard form, that makes it hard for us to guess where the vertex of the parabola will be. So, one of the other main ways we write quadratic equations is in vertex form, which shows us the x and y coordinates of the vertex. Vertex form can look pretty different from standard form, but they're just two different ways to write the same equation. And we can prove to ourselves that they're the same because when we FOIL the vertex form of a quadratic equation, we end up with the standard form. Finally, we learned how vertex form shows us the coordinates of our vertex. The y-coordinate of our vertex is the positive or negative number at the very end of our vertex form equation. The x-coordinate of our vertex is whatever number we can plug in for x inside the parentheses to get an answer of 0. Remember, if you don't see a positive or negative number inside the parentheses or at the end of your vertex form equation, it just means that you have plus 0 in that part of the equation. So your coordinate for that part of the vertex will be 0.
Hey, Mr. Caldwell, I think Dr. Rick's potion finally wore off.
I think you're right, Bones. And just in time, because we've reached the end of our lesson. In fact, we've just finished our 3 lessons on the 3 forms of writing quadratic equations: standard form, factored or intercept form, and now vertex form. So we're ready to move forward and learn about actually solving and graphing quadratic equations. I'm looking forward to that. Keep working hard, and I'll see you next time.